evening, everyone. And a warm welcome to all the participants joining us around the world. So before we begin, let me share a quick housekeeping notes. We have six distinguished speakers. They will present short segments of around 10 minutes each presentations. So all the participants, they will remain muted throughout the session to ensure that we have clear audio, and speakers will unmute themselves at their turn comes. We do have Q&A session at the end, so please post your questions at the Zoom chat. We will try to incorporate as many questions as much possible. And lastly, this session is being recorded and it will be made publicly available on the WWEA platform after the event. So, with that being said, I'll start off with this event. So, my name, just a quick introduction, is Basit Ghauri. I'm from Renewables First, it's energy transition think tank, and I'll be the moderator for today's webinar, Small Wind 101, which is being organized by World Wind Energy Association, and it is being presented with the generous support of Profik Vintus Measurement Institute. So coming over to the topic, whether you're an energy practitioner, policymaker, student, or simple curious about the decentralized wind power generation, this session will give you a comprehensive introduction to the fundamentals of small wind turbines, their development, their certification, and how the whole process in terms of technicalities work. So, with that being said, I'll start off with our first speaker, Mr. Frits, who leads the small wind section of World Wind Energy Association and has been a long time advocate for community scale renewable energy. So, Frits, over to you. The floor is yours.
Okay. Thank you for the introduction, Mohammed. A warm welcome to this World Wind Energy Association small and medium wind turbine webinar. The World Wind Energy Association is organizing a series of webinars on wind energy and also special webinars to create awareness and promote small and medium wind turbines. My name is Frits. I'm from the Netherlands and I'm co-chair of the small and medium wind turbine section of the World Wind Energy Association. I'm co-chair together with Mike Bergey from Bergey Windpower, who will have a presentation in this webinar. Small and medium wind turbines have many different uses, and many people have found that they are an interesting option for generating the electricity they need. Small and medium wind turbines are defined by their use from leisure, like for yachts and holiday homes, to households, to small and medium enterprises, telecommunication and farms, to villages. Small turbines do have a size up to 125 kilowatts, and medium wind turbines do have a generator up to 1 megawatt. As World Wind Energy Association, we are working on continental and regional boosts for small and medium wind turbines. Boosts based on research of the National Renewable Energy Laboratory in the United States, with an outcome of 1,400 gigawatt potential for small and medium wind for the United States alone. Together with the promotion by the Distributed Wind Energy Association in the United States and the Inflation Reduction Act, this gave a boost to small and medium wind in the United States. National Renewable Energy Laboratories also worked out open source for software to help end users to choose a small and medium wind turbine based on geographical information systems on their own property. This open source software will be transformed for a boost in other continents and regions in the world. A boost for the European Union is on the way, and a boost for Africa is in preparation now. How to boost and implement smaller wind turbines is different from region to region in the world. We have to create awareness, standardized regulations, policies, certification, and at best local manufacturing. As a market, we have to unite, also with the supporting industry. Education, installers, maintenance, spare parts, refurbishment, and decommissioning. The World Wind Energy Association is the only association worldwide that supports small and medium wind industry worldwide. I encourage everyone in the small and medium wind turbine market and the supporting industry to become a member of the World Wind Energy Association. Still 90% of the world's land is surface. Land surface is rural. And 50% of the world population is living there. More than 600 million people don't have electricity at all. Besides the development of the multi-megawatt wind turbine market for the urbanized parts of the world, the parts of the world with no grid, island grid, or wind grids have also the right to get sustainable, smaller wind energy. Multi-megawatt wind turbines are too big for weak grids and have logistical problems due to their size. More small wind webinars will come with a focus on hybrid with PV, storage, and energy management. There are a lot of places that have a solitary wind turbine with a size between 100 kilowatt and 1 megawatt wind turbines. Wind turbines that are aging, and because of the nuisance circle, these wind turbines have a maximum size of the generator, so they can't be repowered. A webinar is planned, a broad webinar is planned with a focus on refurbishment, retrofit, renovation, repair, reuse, recycle, repurpose, and decommissioning of these turbines. But today, our webinar Small Wind 101 provides the essential information one needs to know when choosing and installing a small or medium wind turbine. Practitioners will provide an overview of the market and discuss siting, quality, and certification, hybrid systems and mini-grids, reuse and refurbishment, and special applications. Enjoy this webinar 101 with all the aspects of small and medium wind, from siting to refurbishment. Thank you.
Thank you, Frits, for the great introduction about what this webinar is about. Next, we have Mr. Patrick Jüttemann. He is the founder of one of the most comprehensive online resources on small wind technologies and their practical applications. He will provide an overview of the current global market, key trends, and insights into how small wind is evolving across different regions and consumer segments. Over to you, Patrick. Please go ahead. Patrick, you are on mute. If you can unmute yourself.
I'm going to share my
Thank you.
screen.
Yes, please.
Can you see my slide?
Yes, we can see your slide now.
Okay. So let me pull this over just a second. Okay. Yeah, well, hello everyone. Thank you for joining the webinar. My name is Patrick Jüttemann. I'm a neutral expert and author from Germany. And yeah, I'd like to thank the World Wind Energy Association, for this invitation. I give you a small overview of the wind turbine market. We look at the different types of products available, different sizes, typical applications, and this will also, a quite honest and critical look at the market, separating proven technology from marketing hype. Defining small wind, the primary goal is self-consumption, so this generating electricity to power your own farm, your business, your sailing ship, or it might be also private home. And this naturally means that this is a decentralized location. The turbine is installed where the power is needed, and obviously the key differentiator to the big turbines is the height. In practice, the total height of small wind turbines is mostly below 50 meters or 165 feet. This has the advantage that we have a very low visual impact on the landscape, and we have a very wide power range. Starting at the low end with micro wind turbines producing a few hundred watts, probably for instance for a sailboat. But then on the higher end, you can find commercial wind turbines up to 100 kilowatts or even more. That's a matter of definition, because there's no universal standard internationally what constitutes a small wind turbine. So it depends on the national policies and building rules. What is a small wind turbine, a decentralized wind turbine? Now this illustration shows you, gives you an impression of the sizes. Well, here we have a modern megawatt wind turbine with a total height of 230 meters or about 700 feet. And here we have 3 small wind turbines, and let's take the largest one with a height of 50 meters, and you see, well, it seems tiny in comparison. Well, it's a challenging market with pitfalls, and I think it's always helpful to compare it with the solar market, because the small wind and solar market are 2 completely different worlds. The solar market on the one side here, we have large companies worth billions. The market is consolidated. The solar cells and solar panels are mass produced in highly automated factories, which results in, rather consistent quality of the products and low costs. But on the other hand, we have the small wind market. Here we have, instead of few giants, we have several hundreds small and medium-sized manufacturers across the globe. They produce in smaller series, which naturally leads to higher costs per installed kilowatt power. The result is that we have vast differences between the products, and you find huge variations in technology, in build quality, in storm safety. So this means not every small wind turbine on the market is storm-proof, is reliable, and recommended. So this means, as a key takeaway for the buyer, beware. Your own research and due diligence are crucial to avoid a bad investment and to make a good investment, because there are high quality, very good wind turbines on the market, but you have to do your research. Which products are those? Well, when you browse the markets, you see a lot of different designs, and most of them fall into 2 categories. This is horizontal axis wind turbines and vertical axis wind turbines, depending on the rotor axis. And let's first have a look at the horizontal axis wind turbines. This is the industry standard. Here we have to say we have the most, this is the most aerodynamically efficient design. they can capture most energy for a given rotor size. This is a mature, proven technology that dominates the global wind power market, both large and small wind turbines. And then, especially in the wind and the small wind power sector, we have the vertical axis wind turbines, which is rather a niche player. They are often praised for their unique aesthetics and are often marketed as being very quiet. However, they have a well, aerodynamic disadvantage as one side of the rotor moves against the wind, and this limits their efficiency. So I would say, as a key takeaway, state of the art are the horizontal wind turbines. When you look for a wind turbine for professional applications. Now we're going to show some typical applications. Micro wind turbine, a private wind turbine, small wind turbine, and a commercial turbine. The first one is a micro wind turbine. This well, very small capacity, typically systems under 1 kilowatt, and their primary job is, well, it's off-grid, it's battery charging. And what you see here is a very common application on a small wind turbine mounted on a sailing ship. You also see, of course, similar systems onshore, on land, used for, let's say, remote telecom stations or scientific monitoring equipment. And of course, also private homeowners can use a small wind turbine. This is an example from the German countryside. This turbine has a capacity of 5 kilowatts, has a 5 kilowatt generator. The turbine has a total height of 12 meters. And systems for private homes, I would say, generally range up to about 10 kilowatts. And while this turbine is grid connected through an inverter, feeding power directly into the house and offsetting the owner's electricity consumption, and the surplus energy is fed into the public grid. And this photo also illustrates the most critical success factor for a system like this. It's the site, it's the location. Here we have an open rural location on the countryside. You need a location that benefits from strong winds coming from the prevailing wind direction. And keep in mind that buildings and trees nearby are blocking the wind. So this also means that in densely built residential areas, there's mostly not enough wind for a small wind turbine. And now let's have a look at commercial usage. Here you see a 30 kilowatt wind turbine with a maximum height, so that's the highest tip of the rotor, also 50 meters, so that's about 165 feet. This is at a farm in northern Germany in a coastal region. It's also an on-grid application, and its main purpose is to cover the farm's own high electricity demand, and the surplus power here is also fed into the grid. And well, I think it's a key point when we talk about on-grid small wind turbines. I think the best operators are businesses with high electricity consumption, electricity demand. Like, think of dairy farms with their cooling and milking equipment. Think of manufacturing facilities or water treatment plants, because they have a high and consistent electricity demand. They can use large portion of the generated wind electricity. And those larger turbines, compared, for instance, to home wind turbines, those larger turbines, they benefit from better economies of scale, which lowers the cost of every kilowatt hour they produce. Now here on this illustration, you see that there's a solution for every energy demand. Well, this here is at a site, you can see it here, at the site with 5 meters per second mean wind speed. This relates here to the annual electricity production of the turbines. And you see that we have a small private turbine. See this one generating 2,700 kilowatt hours per year. This one even 11,000 kilowatt hours. And here, those commercial turbines even produce 70,000 kilowatt hours, or this one here, 270,000 kilowatt hours per year. I dedicate this slide to a specific phenomenon that is very common in the small wind sector. Let's call it the shiny object syndrome. What does that mean? When we all, we all like powerful attractions and like something new and exciting and supposedly revolutionary. But in this market, it's a dangerous trap for uninformed buyers. So how does it work? A manufacturer startup launches a turbine with bold marketing, claiming their game-changing turbine will outperform everything else on the market. How do they look like? This most in a very unusual rotor shape. They're often vertical axis wind turbines, sometimes also for urban areas. And then we have the problem that there's amplification on social media. You find, for instance, on YouTube, you find clickbait videos with sensational titles like 200% more power or 200% more efficiency, generating millions of views, but creating a completely distorted picture of the technology, as I believe. What is the reality? I'm observing the market now for 15 years. And it's almost every month is coming a new type on the market. But if you follow this, if you follow development of those manufacturers, then you see they leave the market. They leave the market. So the claims are not proven, so to say. And but the buyers of those turbines, they had a bad investment. The solution is stick to proven technology. And if you wonder how those shiny objects look like, those are just 2 examples of probably 50 I have on my hard disk. This one here is a German. This was a German manufacturer with this turbine here, vertical axis, and this one here was an American manufacturer. They had both big announcement and promises made, and those promises could never be fulfilled. I talked with a guy who bought a turbine like this one, and he spent thousands of euros. And this was a German operator here, a German house owner, a private house owner. He spent thousands of euros for this turbine here, and he had almost no electricity produced. So please be careful. The key takeaways are: it's a challenging market. We have many manufacturers with varying quality. Stick to proven technology. Those are generally horizontal axis wind turbines. That's the industry standard. And be skeptical concerning the shiny object syndrome. Very important, check your site first. Always assess your wind resource and be very careful in residential areas, because they are often not suitable because of low winds. And the ideal use case for on-grid small wind power are companies with high electricity consumption. So that's about it. Thank you for watching. And I don't know if people are going to what about the question right now or after all the other presentations.
Thank you, Patrick. And I think we will have the questions at the end, but
Okay.
if there's any pressing questions in between, we can write it, like participants can write it in the chat box. We will try to take them as well. So thank you for that excellent overview and taking us through the catalog of products and the technical specifications and success factors of these different types of turbines. For our next presentation that focuses on quality and certification, which is a crucial area for building user confidence and ensuring safety and performance. So we are joined by Mr. Sven from Teroc, who will walk us through how quality assurance systems, standards, and certification processes are shaping the small wind product. Sven, over to you.
Thank you very much. And I'm getting ready here to share my screen. So you should now see the first slide in my presentation. I work for Teroc, a small consulting company based in Sweden, and have worked with both large and small wind turbines during the last 30 years approximately. And when it comes to quality and certification, a good starting point is the World Wind Energy Association's website about small wind. There you can find some information about what to think about as a buyer of a turbine, especially. You can find some information about the standards that are available and which small wind turbines can be certified to. But there is more to this subject, and some other important points which I wanted to bring up here is first the different natural conditions around the world. So wind, corrosion, temperature, etc. Can have a great impact on a small wind turbine, and this is not the same everywhere. So what works well in one place might not work long in another place. So something which has demonstrated a good quality in say a calm onshore location could fail completely on a windy offshore location, or maybe on a mountain top with low temperature and ice covering the turbine in the winter. And also, quality is not only something that we normally want as a buyer of a wind turbine. It's something that we sometimes must ensure. And this is something I will explain more. Sometimes I have earlier presented this strive towards quality like a staircase, as I do here. And the idea here is that the floor is to fulfill mandatory safety requirements. In the European Economic Area, this would include proper CE marking. On other markets, there would be other mandatory safety requirements. And the next step could be to carry out proper type testing regarding power performance and noise typically. This would be documented in a test report, and for small wind turbines, the IEC consumer label can display test results in a condensed and comparable way. Going further, even better is if you also have third-party type certification. So that means the type of wind turbine is certified by an accredited certification body to a certain standard. And this involves not only some testing, but also a design review and more. And this can be linked to incentives. And then I have in this presentation added another step about quality system, because the small wind turbine is not quite there yet, but it would be desirable to go there, and that's to have a quality system for the manufacturing, for example. And regarding this top step, a quality management system can define a structured way to meet expectations. For example, how to handle different versions of the product can then be described in a quality handbook. And if you're certified to this standard, the certification body will sometimes inspect that you follow your procedures for this. But as I said, we are not there yet. So I think we need to start from the base, the mandatory requirements, and then type testing, and then hopefully also more certification to relevant standards. And this presentation uses Sweden as an example. We are part of the European Union, so most of what I say would be applicable to the EU and also other countries like Norway, which are part of the European Economic Area, using the same requirements. But here, when you build something, the commissioner of a building project is responsible for technical workmanship and review of the design. How can this responsibility be handled? I mean, it's not practical for every buyer to start reviewing all the drawings of the manufacturer, for example. And that's where this third-party certification by an accredited certification body comes in as a very useful tool. So if they have done this review and that is trusted, then it's a way of fulfilling this. And this is the standard procedure, I would say, for large wind turbines. However, certification is done to different standards. And therefore, we can have this strange situation that a small wind turbine can be properly certified to the International Small Wind Turbine Standard or to a similar foreign standard, and it can still be illegal to sell in the European Economic Area. And the problems that I often encounter with CE marking of small wind turbines are first, practical problems, like the braking system does not fulfill the European Machinery Directive. But also the documentation does not fulfill requirements or is not available. So you can have a great turbine which works well, but if the documentation is not there, it would still be illegal to use. Also, please note that I'm writing CE marking. This is not normally a certification done by a certification body. Now, there are different approaches from the industry to address these problems. And the first one, which I recommend, is to fulfill the requirements. And this has normally been the approach for large turbines and has worked well there. But other approaches are to ignore them, fake it, or try to change the requirements. And coming back to the CE marking, it's a self-declaration by the manufacturer or importer. And my experience is that it's difficult to do for an importer of small wind turbines unless there is strong support from the turbine manufacturer / designer. And that's not always the case. And to make things complicated, a wind turbine is usually not only considered to be a machine. Building codes need to be followed too, and they are normally national. And then we have the grid codes. I'm near the end of my presentation, so for the discussion later on, I would be especially interested to hear, does Denmark have a type approval scheme that solves these problems? Maybe someone from Denmark can explain more about that. Thank you very much for your attention. This is how you can reach me if you want to contact me in the future.
Thank you, Sven, for the overview of the quality control steps for these wind turbines and different testing and standardizations that are available, and also the critical factors to ensure that the operation is successful. So for small wind projects, it starts with the right side. And to help us understand this better, we have Mike Bergey, who is founder of Bergey Windpower, a pioneer in small wind industry. He will explain the fundamentals of siting and resource assessment and key technical considerations. So over to you, Mike. Mike, we can see your screen, but we cannot hear you.
Yeah.
Yeah.
So I opened up my screen. It covered up my mute button, and so I had to retrace my steps. Sorry about that. But let me get teed up here, and now you should see my slides and be able to hear me.
Yes, it's visible.
Okay. Let's get the. Okay, well, my thanks to the World Wind Energy Association for the opportunity to participate in the webinar, and I must say I really enjoy co-leading the small wind section of WWEA with my good friend Frits. My name is Mike Bergey. I'm president and CEO of Bergey Wind Power Company. We're a manufacturer of small wind turbines in the U.S. This is my 49th year in the industry, and my company has done something over 10,000 systems that have been installed in 120 countries around the world. We're a market leader in the sizes that we make. So I just want to talk about siting. You know, we could spend hours on it, but I want to hit the high points for those of you who are considering a distributed wind system or a small wind system. So the first thing to understand is that the power in the wind varies exponentially with the wind velocity. So it increases, the power available increases with the cube of the wind speed. And wind speed increases as you get higher above the ground. So tall towers are often needed to both maximize performance and to reduce the effects of turbulence. And I'll talk about turbulence in a few minutes. And I fully realize that this may require special planning permission, hassles, time, investment, but it is worth the effort to make sure that you put a small wind systems where it can operate effectively, and that means at a proper height in most situations. There are formulas for figuring out the increase in wind speed and therefore the power available or energy available with different heights. The math depends upon the roughness of the terrain. So wind speed increases more slowly above water, but increases very rapidly if you're in a forested area. And so your dealer or manufacturer can help you understand that for your particular site and what kind of terrain that you have. And it's very important to minimize the effects of turbulence. And turbulence is nothing more than rough air. If you fly on an airplane and this fasten the seatbelt sign comes on because you're being shooken around and jostled, that's turbulence. And it just like it shakes the airplane, it shakes the wind turbine, and it also affects the aerodynamics. And so it reduces the performance, and it increases the wear and tear. And in spite of some claims, as Patrick has covered, that you may see on the internet, there is no technology that is immune from the effects of turbulence. If a wind turbine manufacturer says it's great for turbulence, go another way. So there have been a lot of building-mounted small wind turbine projects, particularly in the UK and other parts of Europe, and also here in America. But these have all suffered from serious issues with poor performance, noise, vibration. It is just not recommended. Just don't do it. Is the lesson from hundreds of installations that have not done well. And even worse is to consider building integrated wind system. This is an architect's wild dream. It's a very bad one. That should be avoided at all costs. If we have at Bergey Windpower, we've turned down dozens of architectural firms that wanted to work with us to put our wind turbines on buildings or integrated with buildings, and including the replacement of the World Trade Center in New York City. We turned down Arup, a major architectural consulting firm, because it was just such a bad idea. And fortunately, we convinced them to not do it. So the takeaway that I'd like you to believe in is that if you're going to put a wind turbine in an urban area, you're going to suffer such bad performance that you really don't want to even measure the energy. You can do it for aesthetic reasons, for branding, that sort of thing, but you're not going to get any decent performance. So if you're going to put a wind turbine in an urban area, do it for the looks, not the energy. So what about towers for small turbines? Here's an important way of thinking about it. If you put a wind turbine on a tower that is too short, it is the same thing as mounting a solar module in the shade. It's just not good engineering practice. You won't be benefiting yourself or that machine by putting it on a short tower in a turbulent area. So we recommend, based upon thousands of installations all over the world, the tower should be at least 18 meters or 60 feet. Now, I understand that it's common practice in places like the UK to put turbines on 15-meter towers because that's easier to get planning permission for. But it's just not good practice, and we think it's worth the effort to get a proper height tower. If you've got trees, you're going to be need taller towers, because the tree blocks the wind and creates turbulence, and and buildings do the same, and so you need to be above those. Taller towers do cost more, but they nearly always lower life cycle costs because the wind turbine performance is better. There's less maintenance because there's less wear and tear due to lower turbulence, and you get a longer operating life. So please don't use short towers. What's the rule of thumb? So there's no exact science. You can't see air, so you can't really measure turbulence. You can't tell, where it's particularly bad. And of course, it varies with wind speed and wind direction. So the industry has found reasonable success in using a simple rule of thumb. The center line of the rotor should be at least 10 meters above any obstacles within 100 meters. And you want to pay particular interest to the prevailing wind direction. So if you're, say, coastal and you have an inland outland wind flow, make sure that the obstacles that are in those directions are the ones that you're paying attention to. And with that, that's how you site a wind turbine for full effectiveness. And I'll be happy to answer any questions when we get to the Q&A period. Thank you very much.
Thank you, Michael. And it's great to listen to all these factors because we do see a lot of interest from urban centers at times talking about wind resource availability just in their backyard. So I do have a couple of questions, but we'll come back to that at the Q&A sessions. So thank you for that. Moving on, we have Mr. Martin Helmhart from Superwind, who will present on exploring how small wind systems are used for some specific applications. So, Martin, over to you.
Hi, and thank you for sharing, yeah, or giving me the opportunity to talk today here. I'm trying to share my screen with you. Yeah, does it work? No, it's the wrong one, sorry. Okay, now we are ready to go. So yeah, thank you again for the invitation. My name is Martin Helmhart. I'm talking on behalf of Superwind on the usage of or special applications of micro wind turbines and its challenges. So right now we heard a lot about small and medium size of wind turbines, but it's what we do here in Bonn, in Western Germany, are even smaller wind turbines. So some history about our company very quickly. So for 20 years now, we are producing micro wind turbines with an output of 350 or 1,500 watts. So rather small wind turbines. When we started 20 years ago, we mainly focused on this classical niche market that Patrick Jüttemann mentioned. So in that days, PV was very expensive and there were not too many other producers of those small wind turbines. So it was a small world. But with time, things changed. As Patrick Jüttemann mentioned, it's a challenging market. And due to our design features, which I will explain in some minutes, we moved from this leisure market into what we call professional market, professional applications with their own demands. So what I want to tell you now or show you some application types. But before that, I wanted to show you the challenges of wind power, but Mike Bergey, I think, explained it much better than I ever could. But the message I want to give you is the challenge is what Mike already mentioned is wind speed, and wind power is a cubic function. What does it mean? If there's little wind, there's no energy to be harvested, no matter what kind of wind turbine you are going to use. But when there is wind, there can be huge amounts of energy available, which is good from a energy revenue side, but which is a challenge if you are a producer of a wind turbine. So you have to make sure that it's still safe in operation. The storm proof that Mr. Jüttemann is important to be mentioned. So I just have to make references to the others. When we are speaking about micro wind turbines, they're usually mounted in very low altitudes, heights. So typically below those 10 meters that Mike Bergey was looking for. So I'm sorry, we are even lower, but it has some reasons I will show you. But in this low heights, we have even higher turbulences, which creates more stress on structures. We have more load cycles, which means you have turbulences. So the wind is coming, so you have gusts, then you have no wind. So there's a lot of movement. In the end, that creates a lot of stress to any machines. And being that close to the surface, we are also close to salt water. If we're close to the sea, to dust, to debris, to all kinds of stuff. So it's stressful being a small or micro wind turbine if you are placed in a exposed site, and that's what we are right now focusing. So as Patrick Jüttemann mentioned, it's a challenging market, so that's why we moved to niche markets where the climatic or weather conditions are really demanding. So we have high winds, turbulent winds, we have cold temperatures. This is where our super wind turbines are doing its job, and mainly because of this design features that we developed. So we have our wind turbines. They come with an integrated rotor blade pitch control, like the big wind turbines. That means when there's a lot of wind, they change their angle passively, so there's no external control needed. This way we can keep the rotational speed steady, keeping the stress on the structures low and ensuring energy production even under stormy conditions. And one of these applications, for example, which are pretty exciting for us, are measuring buoys in the open ocean. So this is a Typhoon Matmo from this year in Southeast Asia. So these kind of buoys, they are all over the year in the ocean. They encounter water, wave impacts, as you just have seen. They suffer extremely high winds, in this case up to 170 kilometers per hour. And we have this salty atmosphere and water impacts. Another challenging application for us are Arctic environments, like this one that's from Svalbard. So challenge here are the deep temperatures, down to -40 degrees and so on. And the challenge here then is, so you have to be material that works in these conditions. You have to work with bearings which are still flexible and greases which are still flexible in these temperature regions. So that's another application for us. This site, for example, is powering a seismic station as part of the Comprehensive Nuclear Test Ban Treaty. So there's a wide network, and some of these places are in remote Arctic places where PV or other sustainable energy sources do not work that well. So combination of solar in summer and winter gives good results. And another application for us, I didn't find a good video for this, are places close to the sea, like this coastal watch out from the National Coast Watch Institution. So they are placed on the western shore of Great Britain on top of cliffs, so they have a good overview. So they're looking for stranded boats and people who are in the water who need help. So they are very high altitudes on cliffs, have a good overview. And the wind, which is coming from the west, hasn't seen any obstacles since it left, I don't know, so a long distance. So these places are highly turbulent and encounter also big high wind speeds. So these applications are demanding for all kinds of wind turbines. And as Patrick Jüttemann said, you have to watch out what kind of material systems you are using. And yeah, we mainly focus on these niches. So lighthouses, buoys, and Arctic monitoring stations are powered with our stuff. And even last year, we were able to equip a racing trimaran that was racing around the world with up to 100 kilometers per hour around the globe in 50 days. So that's basically it. So our applications are always demanding, and our technology is giving good results. And if you have later on questions, I'm happy to answer them or try to answer them. Thank you. That's it.
Thank you so much, Martin, for going over these special applications of small wind turbine, where most of these where we don't have other options available or either not economically feasible. So next we turn to hybrid systems and mini grids, which is essentially the future of resilient and decentralized power systems. So we have Mr. Hans Fredsted from Moveair, who will discuss how the small wind integrates with solar storage and other technologies to create a stable and sustainable hybrid solutions. So over to you, Hans.
Thank you very much. Do I go clear through? Can you see my screen?
No,
No,
can
still
you
not.
No?
Can you see the green arrow at the bottom?
Yes, I'll
Share?
see. All right. I think this is the right one.
Yes.
You see it now?
Yes.
Perfect. Very good. Well, let me see if I can do it on full screen. Okay. It's better. Okay. All right. So thank you very much for listening in today. I am the Chief Commercial Officer from Moveair, and today is also our Chief Technical Officer is also attending, Kerstin Bart, in this call. First and foremost, as our tagline is saying, energy, anytime, anywhere. If you look at the future and where we are now, the grid is actually the Titanic. And what they're doing at the moment, what's happening in the world, they're actually rearranging the deck chairs. So from my point of view, centralized energy is actually to some extent outdated and fragile. And that's where we, small wind combined with turnkey systems, will represent the lifeboats for modular and intelligent systems that can integrate anywhere. So first thing first, here we have an overview of the agenda for today. I won't talk so much about Moveair itself, other than the company was founded in this company in 2024 on the back of a development that was done with a pre-company for developing modular small wind turbines with the university in Berlin. And we are set on this earth to unlock decentralized energy wherever there is a need in the world, together with all the rest of you here in this room. So when we look at the markets and the growth and where does it come from, we're all aware about that. Despite the developments from latest, particularly in America, there is a push for CO2 neutrality, and that is the best estimate driving incremental investment for the next 25 years of around 40 trillion. And in that area, when you look at where we sit combined with the other energy forms beyond the wind, the microgrid systems represents around 12 to 15 trillion. And that's where we will come in and help to solve the problem with micro wind combined with hybrid energy, so we get energy independence, security, and we use the existing infrastructure. And on that note, I would like to address on the next slide, as you see, the actual markets, addressable market for the mini wind turbines combined with solar and battery is estimated to around 200 to 300 billion in this period of time, and it is growing with around 8 to 10%. So the key drivers are the off-grid reliability, infrastructure, and independence and security. And with hybrid systems, you go far beyond with a singular wind turbine and singular approach to the market to grow the markets. And that's also where we will, with mini wind turbines, increase our footprints and be able to scale globally. There were early on some discussions about where you can mount and where you can integrate and which infrastructure you can use. Yes, for sure there are challenges, but if you focus on the areas where you have the micro turbines from the 500 watt up to the 2000 watt, it is feasible and manageable, and also be successful in delivering successful yields. Spoken about that before, is indeed the challenge for this industry, and have been over years. I was told by Stefan from the World Wind Energy Association that when you go back to 2008 Wind Husum Fair, there was around 14 small representatives of small wind at there, and on top of that they were represented that day in time, there were a lot of topics on the agenda and keynote speakers around small wind. Today, in 2025, there was actually only one, which was us. So what has happened with the industry? There have been a lot of cowboys out there, been flooding the market. It's also was discussed early on and shown with products that actually do not deliver. And that lack of quality and standardization and also mass production is a major issue for challenge for the industry. On the other hand, is also our opportunity. So that's why we need collectively together to build engineering standards that for approvals to get on the market in a way that we will actually increase the quality, and furthermore work together on automation and standardization of the production and mass scale at the end, so we have the quality that can enable us to grow globally. So what are the global trends? I think we're going in direction of an irreversible shift to more energy autonomy rather than only centralization. And that is our opportunity. Beyond the grid outages or shortage and natural disasters and so on and so forth, we have very difficult and fragile situations around the new sphere of geopolitical issues, including trades, and with also war in Ukraine. So that is for sure and indeed our opportunity to knock on the door and break it in and grow through decentralization with our platforms integrated with turnkey solutions. So the demand on top of the beyond energy security and decentralization is that we also have a high in need of increase in electrification worldwide. It be on that mobility is with electrified cars. It be on that we have the massive growth of global AI central or smaller data centers as example. And that will at the end bring forward the possibilities and opportunities for us to make that our presence at a completely different level and place where we are today. What also is happening is the governments in various of countries are looking heavily into how they can run and manage and operate with decentralized platforms rather than central. So scaling the growth opportunities across the board, it's all about standards, partnerships. We need to use AI and bankable energy storage. So to achieve that, we are indeed dependent on industries and organizations like this will help to and support align with on all the ISO standards, the AC, DIN, and so on and so forth. And that we are implementing structured testing environments across. Furthermore, what is for the scaling and is indeed needed and essential is a partnership across the globe on manufacturing and deployment. So co-manufacturing with certified partners, Europe, Asia, America, and also when we talk about the small wind, that we with our efforts and time and money and investment into build small wind together in micro hybrid systems that are integrated with the solar biofuels and battery systems. That is where the future lies and opportunity for us. So obviously the role of WWEA as other organizations is that you have to and must promote supportive policies and help us with fundings and community and energy models that will work and can be scaled. And as spoken about before, the harmonization of the market. In addition, that we have very good, solid, founded innovation hubs for development. On that level and in that way, we can achieve energy autonomy, scalability, and hybrid resilience across the globe. So this is just what we are doing and how we are developing in empowerment of the energy demand, where we focus on the decentralized systems, integrated system, the smart financing from converting CapEx to OpEx or sell lease backs, and leading on in this environment with the hybrid integration, also moving towards energy as a service. So that was what I had on that slide. I can show you one more. Is just an example of a solution to a client where we look at it. Obviously, this is illustrative graphical image you see here, as was spoken about before. The tower have to be certainly much higher, but it is where you build mobile units or integrated units combined with all the energy forms, and where you see also based on in this example that when we talk about energy efficiency based on the specific sites, that there is a saving up to 20,000 euros a year by running at a high full 24/7 kilowatt hours every hour. So that was all from my side. Here at the end, I would like to say that the 20th century was built for grids, and the 21st, we will build swarms. And together as the small wind, with this swarm, we will also enable to provide energy freedom in the world. That's all from my side. Thank you.
Thank you so much, Hans. And it's great to understand different sort of market challenges and opportunities. And we wish you the best of luck for your journey going out there. For our last presentation, we welcome Mr. Rob D. Groot from Business in Wind. He will talk about reuse and refurbishment, which is a rapidly growing area, sort of helps the extend the life of small wind components and in the secondary market for it. So over to you, Rob. Rob, you are on mute.
Yes, you're right. Not anymore, I guess.
Yes, we can hear you loud and clear.
Good stuff. I was hoping to be in the office by now, but I'm not, so I'm doing it from the car. I'm just struggling a bit how to see how I can share my screen. Is it a possibility that you put the presentation on the screen as I mailed it yesterday?
Yes, I can do it, but you can try with the green arrow just at the bottom of the screen where you can share.
I see. Yes.
If not, I will put it for you.
I think I've got it here. Are you seeing it?
Yes, it's perfect.
Okay, excellent. Well, thank you for inviting us to be able to tell you a bit about what we're doing in circular wind energy. My name is Rob de Groot. I am commercial manager at Business in Wind. And we are a, well, how do I get to the next page? Probably it's the enter button or not get to the next page.
Just try with the arrow.
No, it doesn't work. There we go. Now it does work. Apologies for that. We are a company from the Netherlands, privately owned, started by a gentleman called Wim Robertse 7 years ago on his own, basically with the goal to give a used turbine a second life. That's what we do, and we have grown now to about 27 people. And what we do is, which divides us from, say, the brokers in the market, is that we cover the whole scope from buying a turbine until, installing and commissioning it at a new second location. So we buy it, and I'll come to that scope later on. We do the decommissioning ourselves, either to give the turbine a second life, but sometimes customers come back to us to also for turbines that we can't give a second life simply because there's no demand, or they're too old, or in a too poor state. And then we sometimes usually use these turbines and these parts to sell them as parts if possible, and if not, then we have to recycle them, of course. And we are ISO certified on the levels you can see on the screen. So what we want to do is give turbines a second life, and basically that means to be as high on the circularity ladder as we can. We don't have influence on refuse and reduce. That's more in the OEMs where they're in their design process, but we can definitely try to reuse, and that's also why we really need to be very selective on turbines we buy, because there's many turbines coming to their end of their life which can't get a second life because they're either too old or they're not the brand which is in demand in the markets that we serve. But that's what our goal is, to buy turbines that we can get a second life. And as an example, we've recently bought 5 E48s in the Netherlands, which are currently 10 years old, which still have a lot of life left in them. That same goes for E70s that we bought in Germany. So that's the kind of turbines that we are dealing with. Also V52, but also on the other hand, recently this year, we also bought V112s in Germany that we are now installing in Sweden for a customer. This is our team. As I said, Wim Robertse is on the left top side. He's the one starting the company. He's been in refurbished turbines for say about 20 years, and the rest has been added over time. Then the question, of course, is why do people consider a used turbine? Because you always say that if you can build a turbine and you can build new, because that will give you the lowest kilowatt hour price. But there's some reasons why people can't build new. Sometimes it's because of height restrictions, for example, where the turbines need to be at a maximum tip or hub height that is for which you simply can't buy new turbines anymore. Sometimes it's logistical reasons. What we see in France now, for example, is that they are the permit time takes so long that they are at the end of their permitting process, and they look back and they can't buy the turbine anymore. And then we can probably help them with a refurbished version of the turbine they initially wanted to buy in the new state. So that is reasons why people go for used refurbished turbines. So a little step back to the scope. This is the complete scope we cover. So if somebody knocks on our door and says, okay, we've got the turbines that might be interesting for you, we start with an inspection. Based on the inspection, we can determine whether we want to buy them or not, and what we need for refurbishment. So that also determines a bit of the budget and the price that we want to give for the turbines. Then we dismantle them. We don't have our we have our own technicians, but we work together with training and transport companies to do the dismantling. We have our own site managers, our own project managers. Then sometimes we sell the turbines as they are to people that want to give them a second life elsewhere. But sometimes we have full installation projects for which we have to do the refurbishment. Sometimes even if it's civils, even do the foundation, install the turbine, commission them. So we split basically our scope into a buying and a selling side of it, and then we commission the turbines, and then we hand them over to a maintenance company that takes care of the rest of the life of the turbine. Can you all see and hear me well, by the way?
Yes, Rob, please continue.
Okay. Some examples of what we do here in the top right corner, you see a project where we dismantled turbines that couldn't be dismantled from the ground because there was simply no space. So we dismantled them from the water, and some from a more beachy area, which you see on the right bottom side. So that's the dismantling part. As I said, we always start with an inspection, especially with gearbox turbines. We do that with endoscopic research as well, but also the site itself is part of the survey to make sure that we can get away with the stuff and etc. Logistics is very important. You can go for the cheapest carrier, but we work with a company that we work with for 20 years already. As Wim has been in the business for 20 years, you better have a smart and good and reliable carrier than a cheap one, and thereby you can come up with solutions like 2 blades on 1 truck, etc., which is saving you much more cost than just going with the cheapest one. Yeah, sometimes we take turbines apart and repair, refurbish parts, and sell the parts as such. That's an increasing important part of the business that we do. So not only selling the turbines as a whole, but also the individual parts, as you see them here. But they can also be smaller parts like ski packs or all kinds of imaginable stuff. Since September now, we are in our new facility, so we can do the refurbishment ourselves and do that based on the inspection, but also based on the customer's wishes on what they want to have refurbished, and we warrant that refurbishment work, of course. Then, if you have turbines or materials that you can't really give a second life as such, then sometimes you can do something else with them. We are working with a company, BladeMate, in the Netherlands to do a first trial with blades as sound barriers along the highway. The initial trial now is horizontal. This one is vertical, as you can see. And this Vattenfall tiny house, which they displayed in many events, is actually given to them by us. They have done the whole construction of the tiny house, but the nacelle was ours, and that was at our facility when we opened it in September. And everybody had to go through that tiny house to enter into in our facility. Some specials that we've done some Brun turbines, which is always tricky, of course, with hoisting. And we have done a very special project on Ascension Island where we had to take down some old turbines and build one new EWT turbine. Well, Ascension Island is in the middle of the Atlantic between Angola and Brazil. So that was a very special project that we've done. I'm going a bit fast, maybe for the sake of time, but I was really asked to keep it to 10 minutes. So I'm doing my best to make that happen. Then, we have our in-house workshop now, in which we can refurbish turbines close to where we are. We are actually developing a demolition robot for concrete towers. Currently, many of these concrete towers are being demolished with a wrecking ball or with dynamite, which in many cases can't be done because it's in busy areas or where farmers don't want to have all the concrete stuff in their land. So we're developing this demolition robot that should sort of nibble down the tower to an extent of to a level where you can do the rest with a very cheap low crane. So that's something for the future. And this is where we currently are. So we have our new facility here with the space for refurbishment. This is where offices are, and here we have basically a bit for the fun of it. We have a tower with a nacelle, a V90 nacelle on top, which you can enter. I hope you see my cursor from here in the top corner of the building. And this is a meeting room where you can sit with 10 people and have a meeting as a bit of a gimmick to, reuse turbines and what you can do with that. And of course, we don't want to reuse them as such, but we wanted to inspire people by doing this with a turbine so that you can think of all kinds of different applications with giving turbines or turbine parts a second life. So that's the quick version of what I wanted to present. Are there any remarks or questions or anything else?
Thank you, Rob. And I think we still have some times for question answers. So we'll open the floor for our participants. If any of us have any questions, just raise your hand and unmute or ask, or you can write it on the chat box. I think okay, so we have a question for Mr. Michael or Mr. Rob. I understand the technical justifications for not recommending building mounted or integrated systems for new installations. My question concerns the buildings and institutions that have already made these investments. So Mr. Rob mentioned some possibilities regarding reuse, but I was wondering if there is any specific conditions or possibilities that apply particularly to turbine installed in a mounted or integrated way. So I guess I'll pass this one to Mr. Rob, if you would like to respond to this one.
I'm not sure whether I understand the question, to be honest.
Yeah, so there's a question about, for the possibilities or, to reuse turbines that are installed in a mounted or integrated way. So sort of like integrated with, I'm assuming with some of the applications that were, earlier shared by, for instance, by Hans, I think, yes. So is that something that is doable for an integrated turbine to sort of go for a reuse?
Okay, I'm sorry I missed the previous presentations, but you say, I'm looking at the chat now, building mounted. So you mean that you put a nacelle on top of a building, right? Am I
think
understanding that correctly?
that's my understanding of the question, but yeah, feel free to respond.
Well, I don't see that happening. I mean, that of course is something that happens, but that's usually very, very small, very particularly shaped turbines. As I know it from my experience, we're talking about E70s here, V80s, V90s, V112s. So that I don't see that combination flying, to be honest. This is really only happening on the towers, as we all know them.
Yeah, let me try. So I think the question relates to urban turbines or rooftop that have already been installed, may not be very effective. Is there something that could be done to improve their effectiveness? And I'm afraid the best answer is yes, move them. Take them down off of the building, take them out of the urban area, and put them where the resource is less affected on a proper site height tower in an area that with good exposure to the wind. Other than that, there is really no fix for the sheltering and high turbulence and other issues with roof-mounted and urban turbines.
Yeah, and that brings.
I
Yeah, go ahead, Rob.
No, I was going to say I don't see that either. I'm not too familiar with urban turbines, to be honest, because that's not really what happens in this region. But yeah, you get lots of turbulence because of the you know, the urban nature of urban circumstances. Yeah, not really my cup of tea, to be honest.
So
Okay,
the questioner said, should we consider them as sunk cost? And my answer to that is yes.
Yeah.
okay. And I do have a follow-up on that, Michael. You know, you talked about this, you know, the urban centers. We do see from some perspective, there's a concept of having sort of artificial corridors within some urban settings. So do you see the viability within these urban centers where you do have those artificial corridors, at least, you know, seasonal or around the year, in terms of the flow as opposed to a typical turbulent flow that we see into the urban systems? Do you see any more better feasibility and viability in such places?
No,
Uh,
I don't. And I think, you know, it's just like, you know, like Patrick said, you know, we have all these bad ideas that keep floating to the surface, keep getting recycled. And, you know, trying to channel wind is a fool's errand. You know, the channeling effect will vary with wind speed, wind direction. It will never be as good as a smooth, well-exposed flow on a proper height tower. So, no. All right.
yeah. And we do have a question about from Hans. Hans, I think that's something, it's perhaps a thought that you would like to answer as well.
I'm sorry,
Well,
Mohammed, who are you calling on?
well,
Yeah.
okay. I don't think I should answer that question. It is more interesting to hear the opinions of the audience.
Okay, so I think we can if anyone would like to answer that, why is small wind turbine still treated like a hobby when it could be the backbone of energy autonomy?
Well, I'll take a shot at that as well. And I'm sorry, I don't mean to hog the microphones, but you know, we have not had the private sector investment in small wind that you have seen in solar and some other clean energy technologies. So it's as Patrick said, it's made up. The industry is made up of small companies, limited resources, limited visibility, and you know, it's climate change is not going away, and governments are, you know, having to do things to address that. So I think that small wind will continue to develop technically, and the companies will continue to grow. There are tier 1 companies with certified turbines in a number of different countries, and I think that the long-term prospects for those companies is good.
Thank you for your answer, Michael. I share the same views. From my side, I'd like to thank you, all of you, to be part of this today and listening on my presentation and of yours. It was very interesting to share an experience. I have to go to another meeting, so enjoy the rest of your day.
Yeah, thank you, Hans. And I think we are at the end of you know, this webinar as well, but you're leaving a good question that I would still like, you know, Sven, if you could perhaps answer this question by Hans. Why do we have global standards for shipping containers, but not for modular energy systems?
Yes, I think this in a way also relates to what was discussed before. The big players here, they are not going to do this for us. The big utilities selling us electric energy, you know, we can't expect them to build a framework and invest in something which is a potential competitor to them. As was said before, many of the companies working in this area are small, developing standards. You know, that takes time, costs money. So you know, it's not likely that anyone else would like do this for us. Those who are involved and want this to happen, they need to do it, and that could be a good thing to do if there is a you know, participation and some things are a bit standardized, like connecting to a 48-volt battery bank is like a de facto standard for many small battery-based systems. I think I'll stop there.
Yeah, thank you, Sven. And I think that's something, you know, as part of WWEA is looking towards is supporting all these standardization efforts as well. So with that being said, I think we are a little bit over our time as well, with 2 minutes over. So with that being said, I would thank you to all our panelists for sharing extremely informative sessions and taking the time out for today's webinar, and also to the participants. This webinar will be made available publicly as part of our Small Wind 101. So with that being said, we'll have more future sessions, and we look forward to spread more information into the future. So thank you all panelists. Thank you to all the speakers and all the participants. We look forward to welcoming you again in the future.
Okay. Bye-bye.
Hey,
Bye
bye-bye.
bye.